Hi everyone, in this video we are going to discuss about precision and recall for classification, which are very useful concepts because they can highlight problems when we are dealing with imbalanced classes. When we talk about imbalanced classes, then we refer to an over-representation of one class and an under-representation of some other class in both the training and the test set. In this slide you can see that we have more examples of the blue class rather than of the red class. Coming back to our loan application, imagine that we have a classifier that is trained on past data of safe versus unsafe loans. We have much more examples for safe loans. Out of the 1,000 examples, we have 995 loans which were safe and 5 examples of unsafe loans. We apply a classifier and we get the confusion matrix shown on the right. We calculate the accuracy and we get a very high number of 99.5%, which will give us the potentially wrong impression that our classifier is good. And it is good in classifying safe loans, but it is very bad for the other class, which is the unsafe loans. When we have imbalanced classes, it is best to use other metrics such as precision and recall, which are calculated per class. These metrics will allow us to understand for which classes our classifier is good and for which it is not so good. Precision for a class is defined as the true positives over true positives plus false negatives, and recall for a particular class is defined as the true positives over the true positives plus the false negatives. Let's see in the previous example, what value does recall have for class unsafe? We see that the recall is 0, meaning that we didn't recognize any of the unsafe cases. This low value in the recall or in the precision indicates that something is not good with that particular class. Imagine now that this confusion matrix was from a medical scenario and that safe was a healthy individual and that unsafe was one that has cancer. Obviously, we wouldn't want to miss any of the cases where people had cancer and we told them that they are healthy. Now let's see some more examples. This is the confusion matrix that we get if we build a classifier for predicting who will live and who will die on the Titanic based on their age, gender and class. We see that the precision for the class died is 0.81, which means that when an individual is predicted to have died, it is relatively accurate in predicting that. Always in the confusion matrix, pay attention which is the actual and which is the predicted class, because there is no standard way of portraying them. Here the actual class is shown horizontally and the predicted class vertically. For the precision, we need the predictions, so we use the vertical sums in this case. Finally, notice that precision is like accuracy, but only for the predicted instances of a specific class. Now let's compute the precision for the class survived, which is 0.73. And now we compute the recall. For recall, we care about all the instances that were actually of a particular class. How many of those did we find? Therefore, think that recall is also like accuracy, but only for the actual instances of a class, not for the predicted ones. And the recall for class died is also high, meaning that we don't miss a lot of people that actually died. Finally, for the class survived, the recall is, we have 243, that's the true positives, those correctly identified as having survived, over the total number of those that survived, that is 350. Let's see this with another example. In this example, we see the exact data instances. What was the original label or class and the predicted one. Since we want to calculate the precision for class 1, we check only those predicted as 1. There are 5 instances. How many of those predicted as 1 were actually ones? It is 4 out of 5, so 80%. When we compute the recall for class 1, we focus on the actual labels. We originally had 8 ones. How many of those were detected or predicted as ones? It was 4 out of 8 or 50%. In this example, you see that the precision is high, but the recall is low. If it predicts something as 1, it is accurate, but it misses to predict many as 1s. Finally, there is a way to merge both precision and recall in a single number, which is called the F1 score. This is the harmonic mean between these two numbers, and it is defined as 2 times precision times recall over precision plus recall. As we mentioned, the precision and recall are defined per class, but we can also try to average the precisions and recalls for every class to get a single number of either precision or recall for the full confusion matrix. Here we can find 2 main approaches. The first one is using macro averaging. It simply computes the average for either precision or recall. And the second approach is using micro averaging. It uses the original definition of precision and recall, but instead of using true positives, true negatives, and false negatives per class, it sums them up for all classes. So every instance is treated equally. Let's see here the definitions. On top you see the definitions per class of precision and recall. Then the micro or the macro average precision and recall are simply averaging the numbers that we have computed before. And the micro averaging will use the original definition and will sum up the true positives and the false positives and the false negatives for all classes instead for only one class. We can see here in numerical examples. For the confusion matrix on the left, we can see on top the precision and recall for classes A and B. The macro precision and recall have low values. This is because the precision and recall for class B are low. Comparatively, the micro precision and recall are higher. And in the slide, you can see the exact calculations. Therefore, what we discussed in this video are the notions of precision and recall. They are beneficial to use when we have imbalanced classes. The F1 score meshes these two numbers, and you also saw 2 averaging variants, the micro and the macro, to compute the precision and the recall of the full confusion matrix.